So, welcome. This is Practical AI. It's a one-credit course in the Department of Computer Science at Temple University. And with that, here's my welcome video. And I thought it's a good way to start talking about AI by showing you a video that took me only 20 seconds to create, which is probably shorter than a mundane, boring welcome slide I would have to create otherwise. All right. So the course logistics, there are no exams. The grades are based on participation, assignments, and a presentation. And we will talk more about that presentation. There is a handout in Canvas with more details about the logistics. The course is interactive, so participation and interruption is highly encouraged. Yep. Without further ado, let's move on to the course. Here, I assume you have no AI knowledge in the beginning of the course. And as we build up on your knowledge, you're going to end up at a place where you have practical knowledge of AI. And by practical, I mean you can identify opportunities to use AI, and you understand what an AI solution looks like. So hopefully that will help you in your career, whether you go into academia or industry, in taking advantage of this tool that's available now. All right, so let's see how we get there. I start by giving you an introduction about ML foundations. By the way, throughout this course, there is almost no math or probability or a statistics discussion. I keep the discussions very broad. We're going to cover a lot of ground, but we won't go deep into anything. After all, this is a one-credit course, and we can't afford staying too long on a given topic. I will give you an intuition of ML, and then we will make predictions with ML. We will use it for classification and regressions. We will use it to make predictions about some outcomes of interest. And this is where we will look at housing prices. Essentially, you get information about the house and try to predict how much that house is worth. We will look at tumors and determine whether they're cancer or not, so on and so forth. We won't stay there for very long. Typically, in a machine learning, 3-credit machine learning course, those classification and regressions and those ML foundations would be the majority, if not all, of the course. But we want to get as much exposure as possible to AI and its applications in this course. So we're going to move on with the foundation that we build in the prior parts. We will start talking about deep learning. So deep learning being a subset of machine learning. And briefly after that, we will move into generative AI, which is again a subset of deep learning. There are various types of generative AI. The one that we will dive into is large language models, or LLMs, and how you can build products with this LLM. Towards the end of the course, we will have a discussion on the societal impact of AI, which is a fascinating conversation. And we will end the semester with your presentations, where every student will show up and talk for 5 minutes about a project that they found interesting. And then we will have a discussion about that with the class for another 5 minutes. So I expect we will spend 2 sessions on those presentations. That will be an opportunity for students to show how much work and effort and dedication they've put into the course, and that gives me an opportunity to reward them fairly for the hard work they've done. And also for the rest of the students to get a flavor of all different things you can do with AI. All right, so so that was the agenda and syllabus of the course. Now let's talk about why you want to take this course. This is a famous quote by Andrew Ng. I encourage you to pause the video and think for a minute about what that implies, what that means. The way I understand it is the same way that electricity started being generated in laboratories and there were proofs of concept that showed that it can be useful in various applications, and then slowly over time it permeated into every part of the society and daily life. I believe, and it's generally accepted within the AI community, that the same is happening to AI. It started off being explored in laboratories, and then the applications were proven in certain areas, and now slowly, or rather rapidly, is permeating into everything we do. And to give you an example of this, it's a trivial, mundane example, which is in the morning, you wake up, the first thing you do is grab the phone and swipe up and you log in. You get into your phone. Well, that is an application of AI known as face recognition, where the image of you is ingested into a model, in a machine learning model, and it predicts whether it's the legitimate user or someone else. And then when you ask Siri to tell you the weather, well, that's another application of AI called speech recognition, which takes the audio and converts it to some text. And when you ask for the weather, well, that is another application of AI called forecasting that predicts what the weather is going to be like. And finally, when you check your social media, that's a plethora of AI applications in play, from those messages that are free of spam, hopefully, to all the security features, your feed and what shows up on the screen are recommended by AI as well, right? So these are some examples of how quickly AI is finding its way into our daily lives. But it's not just that. It's not just the permeation of AI into our lives, but also there are some monumental efforts and big paradigm shifts that are happening because of AI as well. And these are some of my favorite, some examples of such phenomenon where there is there are new chapters in science and in many aspects of life because of AI. So let me show you some.
Is the king in residence at the moment?
Yes, it looks like the king is in residence right now. The Royal Standard flag is flying above Buckingham Palace, which is the signal that the monarch is present.
Try and tell me exactly what they're doing right now, please.
Right now, the ducks are gently gliding across the water. They're moving in a fairly relaxed manner, not in a hurry.
Yes, I spotted one just now. It's heading your way on the left side of the road. Get ready to wave it down.
Great job hailing that taxi. It looks like you're all set to go.
That's a good dog right there.
All right. So that was ChatGPT, and you could have it on your phone. I have it on my phone. And essentially, that's an assistant to a blind person. And if you notice, the last piece of it was really awesome, where the AI helps this blind person to hail a taxi. Another example I want to present here is this paper that came out of Harvard titled Superhuman Performance of Large Language Models on Reasoning Tasks of a Physician, which illustrates, along with many other research papers coming out, that AI can do a superhuman job, meaning better than human, in tasks of or in reasoning skills of a physician, or in many other disciplines, law, medicine, etc. Right? This is one of other of my favorites. So AlphaFold is an AI application for predicting the shape or geometry of proteins based on the sequence of amino acids. This is not an area that I'm very familiar with, but for those who are, it's been told many times that this is actually the holy grail of biology. It opens doors for drug discovery and for many other applications related to biology. And let me give you an illustration of this. Okay, so up here, this is the sequence of amino acids. They're all here. I'm scrolling. And this is the geometry predicted by AI. And it's not just a 2D image. As a matter of fact, I can zoom in and I can look around. Now, before AlphaFold, you would have to spend a lot of time and money using experimental methods to get an idea about the shape of a protein. But now, because of AI, everyone has the ability to have this insight into protein geometry. Some other examples, I try to sample from different domains. This is another favorite of mine.
Movies in your living room and turn them into epic cinematic scenes using nothing but your own computer and this free AI workflow. And to prove it, I'm going to walk you through all the steps necessary to create a full short film using this technique, which I'm going to show at the end of this video. The workflow does all the heavy lifting, transforming your character and making sure that the acting performance stays exactly the same.
So again, building a movie like that would have cost tons of money, and it was only possible within like those large studios like Disney and others. But now you can do it in your bedroom, essentially for free, because he was using an open source AI software. And the last one is very relevant to software engineers, and that's about using AI to create software. And I have an example here. So think about Claude, which is a competitor to ChatGPT. They make these large language models available to end users. And I'm going to ask it to create a computer game. All right, I have some text that I actually got from Claude's demo. Hey Claude, can you create an 8-bit style crab for me? Here it is. And next. Great, can you make some seashells in the same style? Right. How about some clouds? let me see. Right, let's inline this into a simple side-by-side scrolling game, HTML5. While it's working on it, I'm gonna copy the last piece. Here are the clouds, by the way. Said, I love it, let's make it playable. Have the crab jump up and over oncoming shells. Add some styling too. All right, so while it's working on it, the takeaway I'm trying to present here to you is someone without any computer programming skills, with some ideas for what they want a computer game to look like, can come here for free, create that in a minute. And compare to that to the paradigm that existed up until now, which is a couple weeks. All right, so I can start the game here and I can publish it right there. It looks like I'm not good at playing the game. All right, whatever. What is common in all of these examples that I'm showing you is that AI is making knowledge and knowledge and intelligence available to everyone in a way that didn't exist before. I like to compare it to how internet democratized access to information. Similarly, AI is democratizing access to knowledge and intelligence. And there is a big difference between the two. Imagine you develop a disease and you want to educate yourself about it. Because of internet, you have access to all the high quality peer-reviewed papers from anywhere. All you need is your phone or a laptop, and there is the latest paper on the subject that is very important to you related to this disease. But that most often renders itself useless, because even though the information is there in the paper, you are not able to ingest it and understand it because of your lack of domain understanding in medicine. Now, what AI is doing is it make the actual knowledge accessible to you. Now, you grab that paper, dump it into ChatGPT, say, explain it to me like I'm 10 years old. And now explain it like I'm 15-year-old. Now explain it like I'm 20 years old. See, in 3 passes, you come to understand this very well. And even if you had a doctor who was available to you, which is most likely not true, the doctor probably wouldn't be able to explain it in such coherency and clarity. So, and in all these examples illustrate the same thing: being able to make a movie in your bedroom, having access to this protein shapes, generating movie, creating software, and for the blind person to have a free assistant. All right. So I hope these observations, these examples motivate you to learn more about AI, and in particular, practical AI, such that you can get started benefiting from these amazing tools that are now available. All right, so let's get the course started. So far, we talked about the course syllabus and why you should take the course. And now we're going to actually start the course. Let's start by the definition of AI. So we said AI is the new electricity. It's taking the world by storm. But what is AI? What is artificial intelligence? I feel like the definition is very difficult. And the reason is the definition of intelligence is not easy to come by. And it does get very philosophical very quickly. But suffice to say, artificial intelligence is the ability of a machine to do things, to do tasks that we associate with intelligence. It does something that we would consider it to be intelligent, right? So if I have a spam detector and the emails come in and it decides that this one is a spam, this is a good email, and say, hey, that's kind of intelligent that this machine, this bot can read the email and decide if it's a legit or not legit email. That would be an example of artificial intelligence. And now, like I said, what intelligence actually mean, and by extension, what AI mean, is not critical for us. What is really critical is what machine learning is. So we talked about AI being is an ability of a machine to perform intelligent tasks. Now the question is, how can you create such machines? The most popular way is using machine learning. So machine learning is an approach to building machines that demonstrate intelligence, right? And now let's compare machine learning with non-machine learning approaches, because that's where it becomes clear what machine learning is. Well, in the world of machine learning, the way you make a machine perform a particular task is by showing it a lot of examples. Going back to that spam detection example that I just mentioned. If you want to build this bot that looks at emails and decides if they are spam or not, the ML or machine learning approach would be to find a lot of examples from past of good emails and spam emails, and then feed it, show it to this bot so it learns. And then once it learns, it should be able to make those predictions. In the traditional programming world, or in the not ML approach, what you would have to do is to actually sit down and explicitly program the machine to do certain tasks, right? So that brings us to the definition of ML, which is teaching machines to perform tasks without explicitly programming it for those tasks. That is ML. Now, if you look at these two pictures, the one at the bottom, in the traditional programming world, where you have to program everything into the machine to perform the task, or the rules, right? When I say explicit program or rule, they're really, I'm talking about the same thing. Where do those rules come from? Say in the example of a spam email, maybe the rule is that if lottery in the title, it's spam. If email from mom@gmail.com, not spam, you can come up with those rules. But where do those rules come from? Well, in most cases, you have a human, the programmer, the developer, sitting there and obviously typing it into the program, but where did he get those rules from? Most likely he looked at examples himself. He looked at past emails that were spam and not spam, and tried to come up with these patterns, with these rules, so that he can hard code it. Right? So hopefully that is not a surprising pattern here. You have examples, you learn from them, you come up with those patterns, and then you hard code it into the machine to do the task. What's neat here is, if you cover the right piece of this not ML, you see that these two are quite similar, the ML and not ML, in which it looks like ML is kind of similar to humans in how they learn. They learn from examples. I'm going to illustrate this by looking at this mock data set. Say you have price of a house on the vertical axis and the area for the house on the horizontal axis. So this data set has four, let me get my pen. So we have 4 data points. Each of them is one house. What I want you to do is to tell me your estimate of the price of a house that is 1,500 square feet. What do you think the value or the price of this house should be? Most likely you landed somewhere around this $200,000 range, which is not surprising. You probably immediately came up with that number. What is kind of interesting is if you think about how you came up with that, because that's essentially the recipe for machine learning. And what you did here was you looked at these examples, you found a pattern, and here the pattern is kind of like a linear line. And then when I gave you a new input or a new dot here, new x, a new value for the area, you plugged it into that mental model of this relationship, and then you said, hey, if I go up into this line, that's where I will be, right? So that is, it turns out that's how machine learning works as well. And that is, you collect examples of known house prices, so each row being one house here. Feed it into this, let the machine learning figure out those patterns, those relationships. And once you have that, now you give it the area, and then it will make a prediction of the house price for you, kind of similar to how you did it. And this is not just a make-believe example. This is a real application of machine learning, where the websites like Zillow use machine learning to estimate the value of a house. And in our example, I just mentioned the area, and we decided we were trying to predict the house price. But you might imagine Zillow may use thousands of such information that we call feature about the houses. For example, the age of the house, the number of bedrooms here, the number of bathrooms, the school district, crime rate, distance from train station. There's so much that influences the house price, and but the underlying idea is the same. You collect examples, feed it into this machine learning algorithm, and now you can make predictions with it. So the main message so far has been machine learning is about learning from examples. And this is very similar to how babies learn. Now, when you're an adult, you have other ways of learning as well. You can read a rule book, right? You can read the instructions, similar to the traditional programming. But for a baby, you can't give them a rule book. They just learn from examples. And here a child looks at a dog and hears the parents calling it dog, and the child registers that this is a dog. And when they see a cat, similarly, they will register it's a cat. And here the child is learning what a dog is and what a cat is by looking at examples. To the extent that the child would not even be aware of what patterns it has registered, but through those examples, those patterns have been registered. Now, speaking of that, another example of a machine learning application would be building this bot that looks at an image and decides if it's a cat or a dog. In broader terms, this is like a image classification application. And if you remember at the beginning of the lecture, I talked about this face recognition on your phone that lets you log in. That's kind of similar. Now, with the paradigms that I described so far, getting examples and letting the machine learn from those, we come back to the same flow, if you like. First, you collect examples of dogs and cats with their labels. So you say, this is a dog, this is a cat, so on and so forth. Feed it into this. This could be thousands of images. and let this machine learning algorithm learn what about these images make them dog or cat. In other words, map the um, the input to the output, so that once it's done, it's learned those patterns. Now you can give it an image of a dog, and it will hopefully make a correct prediction. The last example I want to give you is of spam detection. And by the way, the word spam in spam email does come from this meat product. Similarly, you collect examples, each row being one email, the content of the email, and whether it were spam or not. Let the machine learn the relationship between the input and output, such that when you give it an input for an email that you don't know if it's spam or not, it can do the job and tell you that this is a good email and should be routed into your inbox as opposed to the spam. Finally, let's think about this calculator. I find it difficult to judge whether this is an application of AI or not, because it's hard to tell if a calculator has intelligence or not. But it's definitely not machine learning, because nobody would program a calculator by showing it examples. You actually hard code the rules of math or arithmetics into it. It would be very difficult to just show it many examples of 2 plus 2 or 2 plus 3 for it to learn from, right? So I hope now we have this intuition about what machine learning is. And of course, in future lectures, we keep coming back to this theme. But I want to end the lecture by talking about why we would even use machine learning for any of these applications. After all, we have another way, which is traditional programming, right? You don't have to teach everything by a way of examples. Let's look at the spam email. Why would we need machine learning for this? Well, it turns out you could sit down and write rules, but it would take years and years, because there are hundreds of languages, for example, and there are so many clever spam tricks that has nothing to do with language at all. But you imagine you spend years with a team of engineers hard coding the rules into your spam email, and by the time you're done, those early patterns that you uncovered are no longer relevant because people have moved on with new spam patterns. In other words, you got yourself into this chase that never ends. You're always trying to keep up. And chances are the performance would be never as good as an ML-based solution. I gave you the example of this lottery thing, but just imagine the email says, congratulations, you won $2 million lottery, blah, blah. And based on all the rules that you have written, that email landed safely in the spam. But what if you actually won the lottery? Imagine how you would feel if your one lottery ticket actually ends up in your spam. Anyways, so that was one. Housing prices. I think it's a little more tractable to hard code this, but still the problem here for hard coding is scale. One is the scale, and the second is the limit of human knowledge. Of these thousands of features or attributes about the house that determine the price of it, there could be these relationships that nobody has ever thought about, but for machine learning, it's easy to figure it out just by seeing a lot of data. And finally, for cat versus dog, I just don't know how you could even come up with any rules, because these are light intensities in individual pixels. I don't know how you could write rules for that. So I hope you're excited about the course and you already have some intuition about how ML works, or rather what ML is. And in the next lecture, we will talk about how it works. All right.